It's good to have you back. I know you've all mastered scientific notation by now. You've discovered that it's a useful way to represent very large and very small numbers. Now we are going to learn a way to work with very large and very small measurements. Do you remember what distinguishes a number from a measurement?
The unit!
These numbers might seem a little unmanageable to work with. Whatever is a chemist to do? Well, you might say that we can write the numbers in scientific notation. This would definitely be an easier way to represent the numbers, but it wouldn't really help us with the size of the measurements. Instead, scientists use metric prefixes to make measurements like these more manageable. Metric prefixes are the backbone of the metric system. There are lots of metric prefixes, but only 6 of them are used quite a bit in chemistry. These are the 6 we will focus on today as we learn about metric conversions.
During this lesson, you will define the metric prefixes mega, kilo, deci, centi, milli, and micro, and use conversion factors to perform 1- and 2-step metric conversions.
Wake up, everyone! Time to take some notes!
While working with metric prefixes, it will be helpful for you to think of one larger thing being equal to many smaller things. You are going to work with these prefixes all through chemistry and physics, and believe me, you will make fewer mistakes if you think of it this way. Let's start with the prefix centi, because it is a prefix you are familiar with. Just like $1 is equal to 100 cents, 1 gram is equal to 100 centigrams. Following this logic, 1 meter would be equal to 100 centimeters, and 1 liter would be equal to 100 centiliters. Easy, right? Another metric prefix you have probably heard is kilo, which is abbreviated with a lowercase k. If you look at the speedometer of most cars, you will see that speed is measured in both miles and kilometers. Kilo means 1,000. A kilogram, therefore, is larger than a gram. So the metric fact is that 1 kilogram is equal to 1,000 grams. Of course, 1 kilometer would equal 1,000 meters, and 1 kiloliter would equal 1,000 liters. The next metric prefix we want to learn is mega, which is abbreviated with a capital M. A megagram is larger than a gram, so we want to think about how many smaller grams are equal to 1 larger megagram. The metric fact associated with the prefix mega is that 1 megagram equals 1 million grams. Next is deci, which is abbreviated with a lowercase d. A decigram is smaller than a gram, so in this case, we think of how many smaller decigrams are in 1 larger gram. The metric fact is that 1 larger gram is equal to 10 smaller decigrams. Have you heard of a millipede, or 35 millimeter film? How about a milligram? Milli is abbreviated with a lowercase m, and 1 gram is equal to 1,000 milligrams. Finally, we have the prefix micro, which is abbreviated with the lowercase Greek letter mu. 1 gram is equal to 1 million micrograms. It is important that you have a good understanding of these metric prefixes. So let's try out a few questions. In your notes, jot down the answers only to the following questions. How many meters would be in 1 kilometer? How many kilometers would be in 1 meter? Which would be larger, a milliliter or a centiliter? Which would be larger, a kilogram or a megagram?
Kilogram or megagram? Kilogram or megagram? Kilogram or megagram?
Which would be larger, a millimeter or a kilometer? What metric prefix would be used to express the relationship between a penny and a dollar? What metric prefix would be used to express the relationship between a dime and a dollar? How many dollars would equal a megabuck? How many dollars would equal a kilopenny? That should be enough questions for now. Let's go over the answers to see how you did. Don't be discouraged if you didn't get them all, because you are just getting familiar with this concept. With practice, it will become second nature. There are 1,000 meters in 1 kilometer. there are 0.001 kilometers in 1 meter. Did you get it? You had to put your math hat on to get this one. Since there are 1,000 meters in 1 kilometer, 1 meter would only be 1/1000th of a kilometer. And 1/1000th is written 0.001. A centiliter is larger than a milliliter. Some students have trouble with this one. Think of drawing a square to represent 1 liter. You would divide your square into 1,000 smaller squares, like a grid, to divide it into milliliters. To divide it into centiliters, you would break your square into 100 smaller squares. Now, which would be larger? One of the 1,000 squares or one of the 100 squares? One of the 100 squares, of course. Therefore, a centiliter would be larger than a milliliter.
Now that we've figured that one out, let's pause just a second to let you reevaluate the next two.
Which would be larger, a kilogram or a megagram? Which would be larger, a millimeter or a kilometer? I hope you all got them. A megagram is larger than a kilogram, and a kilometer is larger than a millimeter. What about the next one? We know that there are 100 pennies in a dollar. We know that we use the prefix centi to show that there are 100 centi-things in one thing. This means there would be 100 centidollars in $1. Therefore, 100 pennies would equal 100 centidollars, or 1 penny would equal 1 centidollar. Now that you understand that one, take a centisecond, take a whole second, to think about this question. What metric prefix would be used to express the relationship between a dime and a dollar? How did you do? There would be 10 decidollars in $1, just like there are 10 dimes in $1. So a decidollar would be equal to a dime. You should be feeling smarter by the millisecond. On to the next one. How many dollars would equal a megabuck? Remember that the prefix mega means 1 million, so a megabuck would be equal to $1 million. Feel free to send a megabuck my way. This last one is a bit tricky. You better put on your math hat. The prefix kilo means 1,000, so a kilopenny is 1,000 pennies. Since there are 100 pennies in a dollar, you would divide 1,000 by 100 to find out how many dollars there are in 1,000 pennies, and you get 10. So, there are $10 in 1,000 pennies, and that means there are $10 in a kilopenny. Not so hard if you take it step by step. Now that you're feeling more comfortable with the prefixes, let's try something a bit different. On these questions, you will need to think about which base unit, meter, gram, or liter, would be appropriate for the measurement, as well as which prefix is needed to make the number reasonable. You can just jot the answer down in your notes. What would be the most appropriate unit to measure the distance from your house in Georgia to Grandma's house in Alabama?
First of all, you needed to determine that you are measuring length, so your base unit is the meter. Next, you had to decide what prefix, if any, you needed to use. The distance from your house in Georgia to Grandma's house in Alabama is too big to be measured in meters because the number would be too large. The two prefixes to choose from are kilo and mega. Depending on which part of each state we are talking about, the distance is about 300 kilometers, which would only be 0.3 megameters. In this case, either kilo or mega would be acceptable, but in my humble opinion, the kilometer is going to be your best choice.
I hope all of you got that one. Let's try another one. What would be the most appropriate unit to measure the mass of a teaspoon of water? How did you do? If you looked back in your notes, which is always a good idea, you remembered that the average paperclip has a mass of 1 gram. So the base unit of gram without any prefix is the most appropriate answer here. Let's work on a couple more. What would be the most appropriate unit to measure the volume of air in a balloon? How about the mass of a single atom? How about the time it takes light to reach the Earth from the nearest star? To measure the volume of air in a balloon, you probably went with the liter or the deciliter. To measure the mass of a single atom, you should have chosen the microgram. In reality, this would still be a very tiny number. For this reason, scientists have come up with a unit just for measuring the mass of atoms. It is called the atomic mass unit. Appropriate name, huh? We will learn more about this later. Finally, to measure the time it takes light to reach the Earth from the nearest star, you would use a megasecond.
Now that you're familiar with these metric prefixes, you are going to learn a skill that you can use in chemistry, in physics, on the SAT, and in real life. There are several names for it: dimensional analysis, factor label method, conversion factors, etc. For some of you, the method may seem to be too basic at first, and you'll think that you can do these problems in your heads. Believe me, the problems will get harder, so learn and follow the method. If you learn to use conversion factors, so much of what we do in chemistry will be easy. If not, well, you'll be...
Let's get started. No matter how simple or complicated the conversion, we always start the same way, with a question mark. The question mark represents how many. If you start the problem this way, you'll know where you're going. So a problem like convert 152 centimeters to meters becomes how many meters equals 152 centimeters. Now some of you have already worked this one in your heads and know the answer. I can work it in my head too. That's not the point. The point is that today we are learning a method to solve problems. Learn the method, and believe me, you'll thank me later. To finish our conversion, we will multiply by a conversion factor. A conversion factor is a fraction that is equal to 1. Since we don't want to change the value of our measurement, 1 is the only number we can multiply by. You know the fact about meters and centimeters. 1 meter equals 100 centimeters. This fact can be expressed as a conversion factor in two ways. It can be 1 meter over 100 centimeters, or 100 centimeters over 1 meter. Both of these are fractions that are equal to 1, so both can be used to convert units without changing the value.
How do we know which of the two conversion factors to use? Well, if you've followed the method and set up the problem correctly, the units will tell you what to do.
Starting with the problem stated in the correct form, how many meters equals 152 centimeters, we will multiply by a conversion factor. We use our units to set up the conversion factor. Since we want centimeters to cancel out, we put centimeters on the bottom of the conversion factor. That makes meters go on the top. Now notice that we haven't put in any numbers yet. Don't try to do two things at once. You'll just set yourself up for making errors. Set the units up to cancel centimeters and leave just meters. Then put the numbers in. It's no more work for you, but it can save you from wanting to kick yourself for making a silly mistake. Next, we put in the fact. The 1 goes with the meter, and the 100 goes with the centimeter. Watch how the units cancel. This leaves only meters. Now, all we have to do is put on our math hat and do the math. The equation tells us to multiply 152 by 1, and then divide by 100, giving us our answer, 1.52 meters. If you set up your conversion in the question mark format, make your units cancel, insert your fact, and then do the math, you'll find that conversions are easy. Instead of trying to figure out whether you should multiply or divide, you let the units do the work for you. And all the writing is done on one line. You try this one. Show your local teacher that you are following the method.
Okay, how are you going to start every problem?
With a question mark.
Okay. Then you want to ask yourself, what are you trying to solve for?
How many grams are in 62 kilograms?
Good.
So grams equals...
Okay, now you're in kilograms and you want to go to grams. So how are you going to get rid of kilograms?
Put kilograms on the bottom so that they'll cancel out.
Good. Okay, and once you've got your units written in, then you need to make sure you put the numbers in, but don't do it in the other order.
There's 1,000 grams in 1 kilogram.
Very good. Okay, now what you want to do is to check to see if your units cancel out. Good. Now what's the answer?
62 times 1,000 is 62,000 grams.
Very good.
In the first example, you divided. This time, you multiplied. When students work these problems in their heads, they often get confused about when to multiply and when to divide. You didn't have to decide what to do when. The units did it for you. That's the beauty of following the method. You don't even have to think. Well, at least you don't have to think too hard. Now let's try a more difficult conversion. Copy the problem using the question mark format. Then, let's work through it together to see if we can figure it out.
Okay, let's go ahead and set up this problem.
All right, so I want to know how many deciseconds there are in 1,700 microseconds.
Very good. And what's different about this problem and the previous problem?
I don't know enough facts to go from here to there.
Very good, but you do know something about microseconds and another unit and deciseconds and another unit. What's that?
They both have seconds in them.
Very good. So what we're going to have to do is do this problem in 2 steps.
Here's a hint. What if you want to go from Cordele to Moultrie, but you couldn't take the shortest route because the road was closed? What could you do? You could take I-75 to Tifton, then go southwest to Moultrie. But first, you have to leave Cordele.
All right, so what I want to do is take microseconds and convert it to seconds.
Good.
All right, since I want my microseconds to cancel out, I'm going to put them on the bottom.
Good.
And I'll put my seconds on the top.
Very good. And once you have your units written in, then you're going to put in your numbers.
Okay, for every 1 second, there's 1 times 10 to the 6th microsecond.
Very good. Now check your units.
Okay, the microseconds cancel out, and I have seconds.
Good. And is seconds what you want?
No, I want deciseconds.
Okay, so keep going.
All right, so I'm going to take that, and for every, I'll put seconds on the bottom and deciseconds on the top.
Good.
Because I want these to cancel out.
Good.
All right, there are 10 deciseconds in every 1 second.
Very good. Okay, so let's do the math. You tell me the numbers to press.
All right, you have 1,700
Okay.
times 10 divided by 1 EE6.
Okay. 0.017.
Decisisecond.
Very good. Good job.
Now try this one. Copy it down using the question mark format. Your teacher will pause the tape while you work the problem. Then, we'll go over it. Local teachers, please pause the tape.
Let's make sure you set it up correctly. We set up the problem as how many kilometers equals 0.056 millimeters. The first conversion factor must have millimeters on bottom and meters on top. Put in the fact that 1 meter equals 1,000 millimeters and cancel out the millimeters. Next, we need a conversion factor that will cancel out meters and convert to kilometers. So meters goes on the bottom and kilometers goes on top. Put in the fact that 1 kilometer equals 1,000 meters and cancel out the meters. Now you do the math. The equation tells you to divide 0.056 by 1,000 and then divide by 1,000 again. Don't put 0.056 divided by 1,000 times 1,000 because calculator guy will divide by 1,000, then multiply the answer by 1,000. Punch divide by 1,000 and then punch divide by 1,000 again. The calculator should put the answer in scientific notation, which is 5.6 times 10 to the negative 8th kilometers.
Did you get that right? If not, make sure your setup is correct, with units canceling out. Then, check your facts.
Many students make the mistake of saying that 1 millimeter equals 1,000 meters. Do a sanity check on your facts and visualize a meter stick and the tiny mm. Don't create an insane fact that isn't a fact at all.
If your facts are right, show your teacher or another student how you punch the buttons on your calculator. You should be able to find your mistake so that you don't go down that road again. The problems are going to get a little harder, but before they do, you need to practice this kind first. Your local teacher is going to put these problems on the board for you to work. When you are ready, I will be back to go over them with you. Copy them, and then your local teacher will stop the tape. Remember, even if you think you can solve a problem in your head, don't. I want you to practice the method before we hit more complicated conversions. Local teachers, please pause the tape for students to work Program 1-4, Problem Set 1.
Now I want you to check your answers. In number 1, you just had to use a conversion factor that 1 gram is equal to 10 decigrams. If you set it up correctly and did the math, you found that 59 decigrams are equal to 5.9 grams. For number 2, you had to use 2 conversion factors. 1 meter is equal to 100 centimeters, and 1 million micrometers is equal to 1 meter. On this one, if you set it up correctly and did the math, you got 9.8 centimeters equal to 98,000 micrometers. It would also be correct to say 9.8 times 10 to the 4th micrometers. Number 3 uses the conversion factor that 1 liter is equal to 1,000 milliliters. After you set it up correctly and do the math, you get 60 liters being equal to 60,000 milliliters. Of course, in scientific notation, this would be 6 times 10 to the 4th. For number 4, you had to use the conversion factor that 1 kilometer is equal to 1,000 meters. Once you set it up correctly and did the math, you found that 1.4 times 10 to the negative 7th meters is equal to 1.4 times 10 to the negative 10th kilometers. The last one, number 5, uses 2 conversion factors. First, you use the fact that there are 1,000 seconds in 1 kilosecond. Then, you use the fact that there are 1 million seconds in 1 megasecond. Setting it correctly and doing the math tells you that 4,500 kiloseconds equals 4.5 megaseconds. If you missed any, I want you to figure out where you made your mistakes and circle them. Then I want you to rework the problem correctly. Your local teacher will pause the tape to give you time to do this. When you're finished, get a neighbor to look it over.
Local teachers, please pause the tape.
Now that you're becoming an expert in conversions, let's try something a little more challenging. How many yards are in 91.44 kilometers? You should know all of the facts you need to solve this problem, with one exception, which I will give you. There are 2.54 centimeters in 1 inch. Get your pencils out and start working. Don't forget to follow the method.
Local teachers, please pause the tape.
Let's see how you did. You should have found that using the method made this problem quick and easy. First, you used the fact that there are 1,000 meters in 1 kilometer. Then you used the fact that there are 100 centimeters in 1 meter. Next came 2.54 centimeters in 1 inch. Then 12 inches in 1 foot. And finally, 3 feet in 1 yard. It is easy to see which part of the fact goes on top and which goes on bottom if you cross out units as you go. Then you don't have to think about when to multiply and when to divide, because the setup does the thinking for you. So you do the math and find that 91.44 kilometers is equal to 100,000 yards. So you see that following the method can turn a seemingly difficult problem into a piece of cake.
You're going to need some more practice with this before you feel totally comfortable. As you may have noticed, I cannot emphasize enough that you should follow the method as you make these conversions. I know how brilliant you are, and I understand that you can do some of them in your head. Remember, that's not the point. I promise you will want to be totally comfortable with this method of solving problems as you complete this chemistry course, as you complete physics next year, throughout your science classes in college, and through many life experiences. You're just going to have to trust me on this one.
Here comes your chemistry quiz. Remember that you do not need to write down the questions, just the letter of your answer. When the tape ends, your local teacher will go over the correct answers with you. Here goes. Here's cumulative review question number 1. Which of the following is in correct scientific notation? A, 16.5 times 10 to the third. B, 3.0 times 3 to the third. C, 1.3 times 10 to the third. D, 0.54 times 10 to the third.
You will need your math hat for cumulative review question number 2. Express 0.0003 in correct scientific notation. A, 0.0003 times 10 to the first power. B, 3 times 10 to the fourth power. C, 3 times 10 to the negative fourth power. D, 0.3 times 10 to the fourth power.
Question number 1 uses your metric prefixes. How many centimeters are in 1 meter? A, 1, B, 10, C, 100, D, 1,000.
Of course, question 2 concerns following the method. What is the first thing you do in any conversion question? A, figure out which conversion facts you need. B, punch numbers into your calculator. C, figure out if you need to multiply or divide. D, set up the problem in the question mark format.
Think about a meter stick as you answer question 3. Which of the following could be used as a conversion factor? A, 1,000 meters equals 1 millimeter. B, 1,000 millimeters equals 1 meter. C, 100 meters equals 1 centimeter. D, 1,000 centimeters equals 1 meter.
It shouldn't surprise you that I want you to think about the method again as you answer question 4. When you use a conversion factor in a problem, how do you decide what should go on top and what should go on bottom? A, use the units to guide you. B, take a guess and hope for the best. C, the larger unit always goes on bottom. D, the smaller unit always goes on bottom.
Remember the road map as you answer question 5. What do you do when you don't know a conversion factor between the two units in the problem? A, make something up. B, give up and take a nap. C, use multiple conversion factors. D, change the problem.
Time now to convert this electronic classroom back into your normal classroom so you can spend some time practicing your metric conversions. Until we meet again, I have only one thing to say to you. Follow the method. Follow the method. Follow the method. Follow the method. Follow the method.